Hey there everyone, this is Mystic Fish and welcome to episode 2 of our Factorio Sushi Spectacular. Alright, we are going to spend this episode going over some of the basics of how the sushi belt mechanisms are going to work. So let's just go over at the beginning just a couple of things that we want. Let's see, let's just grab a couple of the circuit network components here, and we can start to explain how things are going to work. Okay, so let's see, where do we have power? Guess we're done with these, so we can use the power up here. Okay, first thing that we want to track is we're going to have a memory cell. Okay, and this is going to track and remember a count of things that are currently on the belt. And so what we're going to do is we're going to say for each item, add 0 and output the same item. And because this is looped around, it would actually just remember what's in there. And when a new item gets added, if it comes in here, that will get added to whatever is there, and then it will continue remembering. And if an item gets subtracted, like with a -1, it'll subtract it from the count and then continue reminding it. And so the main thing is when we put something on, take something off, we want to make sure that that signal shows up for one tick. So let's show a little bit about how this could work. So let's just set this up here. Let's get an inserter. Okay. I'm going to turn this sideways just for a second. Okay, let's just put here. We'll just put the labs in. That is a useful item. Okay, so now here's what we're going to do. We're going to go. Okay, we're going to connect both sides of this to this green network here, where we can, if we hover over the electric pole, we'll be able to see what's on there. Now, what we're going to do is we're going to say, just be a normal inserter, but read the hand contents. So every time you pick something up, and we'll do a pulse. So what that means is every time I pick something up, we're going to get a signal of what I picked up. Okay, and so if I turn this back around, it should put the 4 labs on here, and we should see this count up here. We can see that it increases every time it picks it up, right? And then it's remembering it, right? So that all works okay. When we want to take something off, we need to do something slightly different. So let's do this. Let's get power. All right, now I need another one of these. Okay, so when we take something off, it's a similar idea. Okay, so we're gonna say, okay, you're gonna do this. We're gonna read the hand contents, pulse. All right, so every time it picks something off the belt, we're going to get a pulse here. But what we need to do is we need to say, give me that thing, multiply it by -1. Because if I pick a lab up off of the belt to remove it from the belt, I am -1 lab, right? And so we're currently at 4. And so what I should be able to do is if I drop a lab onto the belt, it should pick it up. And now... oh, that didn't work because I didn't connect the output. Ha ha ha. Okay. So we need to put this in here. All right, let's take this out of here. Let's try this again. All right, so the inserter is going to pick it up. This is going to turn it into a -1, and that should reduce the count from 4 to 3. Okay, so I'm going to drop a lab onto the belt. We're going to watch here. Picked it up, and now it counts 3. Okay, so this is how we keep track of things going on and coming off, right? And so that means this is what we're going to use the green wire everywhere for. So we're going to hook up this green wire, and it's basically going to be, this is the current count of things that are on the bus. Okay, so we'll keep that there. Actually, we should probably reset this, like so. Okay, so now there's nothing on the belt. Okay, so the next thing is, what we want to do is we want to understand, should I put something on the belt or not? And this is where, actually we won't need this for right now, because we can fake this out with a couple of combinators here. Okay, so let's talk about this. Okay, let's say we've got an inserter. I'm going to turn it to the side just for a second. All right, it's full of labs, and so the question is, should it put a lab? How do we know if we want to put a lab onto the belt? And so what we're going to do is we're going to use the green wire. Remember, is the current count of labs in this case, and the red wire, which again will be everywhere, we're going to set that to tell us what the desired number is. Okay, so let's say that we want to have 2 labs on the belt at all times. Okay, sorry, where are my labs? Here they are, labs. In order to mark it as I want 2 belts, then I'm going to say -2. So you can think of it as I'm too short of what I want. All right. And so then what we do here is, if we look at here, we'll connect this over here so we can also see it. We'll connect these here, and so we can see this, right? We have the -2 signal from the red. Now, suppose we currently have 1 lab on, right? So we're gonna say, hey, the current count here is, there's 1 lab on the belt. We want there to be 2, right? So we really want to put 1 more lab on here. All right, and we can see both of those signals here. So question is, when should this be enabled? Okay, now because both the green and the red signal are coming in here, they'll get added. Okay, so we're currently in a situation where we want a lab. And so if I add these 2 together, -2 plus 1 is -1, right? So that says we are -1 labs away from where we want to be. And so what we can do is we can say, okay, look, you can put things on the belt as long as essentially the supply is less than the demand, right? So here's the supply, it's 1. We add these together. And so if those add up to a negative number, then our demand is greater than our current supply, right? So that's what we'll do here, okay? And we can see this is marked as waiting for source items. Okay. On the other hand, if there are 2 labs on the belt already, then we can see this is disabled by control behavior, right? Because -2 plus 2 is 0, and 0 is not less than 0. Similarly, if we have too much on here, if we have 3 on here, still disabled. If we clear this, meaning we have no labs on the belt, right? Then we have -2, we have 0, that's -2, and it is once more enabled. So that's how we will control. That's basically how we're going to control the inserters that are putting things on the belt. And so whenever we pull something off the belt, we need to make sure we read the hand contents and subtract it from the green wire. When we put something on the belt, we need to have a pulse to read the hand contents and add it to the green wire as a +1. And then we'll use the red wire to indicate how many items we want to keep on the belt at all times. Okay, and that will control for something that, like in this case, we're not feeding things back, but you know, we'll have a source of items, and we will control the inserters to make sure we're only putting things on the belt if our supply is off. Okay, so that's how that is going to work. All right, next step is let's go fix our power business up here. Okay, I think what I want to do here is, well, let's reach down here like this. What I really want is, this is one north of this boiler, and I think we want to come down like, if we do it here, okay. I think we want things like this, okay? We're gonna connect the red wire and the green wire like so, as we said, and then I'm gonna blueprint, let's see, that reminds me, blueprints. Let's put our mining blueprint down here. Okay, I'm gonna blueprint, oh, what happened to my copper cable between these? Oh, I think that's okay. I think that will show up. Okay, so I wanna blueprint this thing. Right, which does have the copper cable and the red and green wires. So I'm just going to create this one just for a second. I don't know that these are going to be the same. I think this is the maximum reach, actually. Let's see if that's true. If I take this off, does it reach there? No, all right, it's not quite the maximum reach, but this is what I need for the power thing. So we'll just put these in here like this, because we are going to need the circuit network stuff for the boilers eventually. So we'll bring these down here, and then we'll paste in our power poles. Okay, that gives us our red and green wires for free, so that's good stuff. All right, we are going to also need to come here. I'm going to clear this stuff out of the way. All right, I think we're going to set up a sort of like a central brain kind of down in this area. So what I'm going to do for right now is I am going to make a maximum length one of these things. I think we're done with this one. Delete you. Let's put okay, we'll blueprint this. All right, I will store that there. Actually, what I will do is I am going to snap to grid relative. We're going to say the width is 7. Okay, then I think this will tile. Yep. Okay, so we need to bring this over here-ish. And we need to bring this down from here. Okay, this is extra. All right, we do need to connect, get around the corner here. Okay, let's fill in the power poles going this way. Okay. All right, this will let us set up our brain area up here. So let's just paste in a few more of these wires. Okay, so first thing that we're going to need is our memory cell, Right, so if you remember what we say, we want to remember how many things are on the belt, and that's going to be with a green wire. Okay, so we're going to connect that here, and we're going to connect that there. Okay, so now we need to work out the demand side of this equation. And for this, I'm going to come one more tile north. Okay. All right, now here's where we start to do some math. So the first thing that we're going to do is let's figure out our rough demand. And for this, we're going to use constant combinators for this. So I'm going to use the factory planner here. So let's just start with red and green science, and it actually doesn't matter how many science per minute we choose, because this is all about relative rates. So let's assume that we want to do 45 of each. Let's put these in here. We're going to need the other recipes. Okay. So that's what's. So this is the full set of things we're going to need on the bus to do red and green science. And more importantly, these are the ratios, right? So we think about it, it's the same number of red and green science, same number of belts as we have green science, same number of inserters as green science, etc. Right? So this is primarily the ratios that we want to have here. And we can do math so that we can just read these right off. So, so I'm actually just going to copy all of those rates down here. So I remember some of these. We did just say belts and inserters were the same amounts. Okay, what else we got? Green circuits, also 45. Okay, we've got gears at 112. Okay, we've got copper cable at 135. We've got iron plates at 337. We've got copper at 112. We've got iron ore at 337. Whoops. All right, similarly, copper ore at 112. And then coal is going to be 100. Okay, if we look at the power, 1.66 megawatts. So we want to know how many coal per minute. We want to convert this to coal per minute. So in order to do that, let's get a calculator. What did we say here? 1.66 megawatts. 1.66 megawatts. That's 1.66 megajoules per second. So in 1 minute, we'll multiply by 60. And then we divide by 4 because there are 4 megajoules per coal. And that tells us another 25. So I think what we can do is we'll also add 25 to this for the power. Okay. So the idea is that we can encode these rates in here. And then what we'll do is we want to assign proportional shares of space on the belt to these things, right? So however much we put on, we want there to be the same number of red and green and transport belts and inserters and green circuits, okay? Same amount of iron plate as iron ore, and obviously there's going to be more iron plate than transport belts. Okay, so that's how we're going to track we're going to compute our demand from this. So now the next question is, how many belts do I have? So I can use the map view to do this. And what I can do is I can grab a blueprint, and we can see that there are 706 belts. If you look at the left end of this sort of blueprint thing. I'm going to hit Q to not do that. But it does mean that we need to track this. So this is a separate number of belts, okay? So this is going to be a constant. We're going to update this over time to record the current count of belts. Okay, so now the next question is, now we're going to start to do some math. Okay, the next question is going to be, okay, if I have this many belts, how much space does that mean that I have on the entire loop of belt? Okay, and so what I can do is I can take the number of belts, and if I multiply it by 8, that should be the total capacity of the belt. So we'll mark that as C. Okay, and what we can see that it's 5,600. And that's because, we put this 8 in here. And that is, in fact, the case, right? If I put a belt on the ground, I should be able to get 8 things on here. Right? Like that. That's a full belt. Can't put any more on there. I think these are actually sitting on the ground where I'm putting them there. All right, excuse me there. But I am actually going to reduce this from 8 to 6. And so we're not actually going to try to fill the entire belt. We'll leave some extra space in there, have a little slack in the system. So we're only going to fill it up 75%, right? 6/8 is 3/4, 75%. So we'll always leave some space, and that way we don't have to worry about, is there enough room to actually put stuff on here? Okay, next calculation that we want to make is, in order to get the ratios here, we have to actually add all of these numbers up so we can turn these into a percentage. So let's grab our desired inputs. We're going to say, okay, for each thing on the input, I actually want the same number, but I'm going to output T. Okay, and you can see that results in something like 1400, and that is the sum of all of the signals that are coming in on the input. Okay, so that T is the total. Okay, so now to compute the demand, essentially what we want to do is we want to take each one of these signals, divide it by T, and that'll give us the percentage of the overall belt capacity that each item should have, right? So in this case, 45 divided by 1400 or so. So let's get this out. 45 divided by 1400. We want red science to occupy basically 3% of the belt. Okay, and then if we know the total number of items that we can have, if we multiply that percentage here, then that should tell us the number of items that we want on the belt. All right, so let's see if we can do this. All right, so let's, we actually have to do this in the following order. Okay, we're gonna get the capacity in first. We're gonna get all of the items in, and for this we'll use a different wire. Okay, so this has all of those input items plus the capacity. And so what we want to do is we want to say each times C output each. And so that will multiply all of these things out by a pretty big number. And then what we'll do is we'll take this output from here, We'll take the T from here and we'll say, okay, give me everything divided by T. Output each. Okay, and that should be the demand. Okay, so let's see if this works out, right? So that says we want 127 red signs if we look down here at the output signal. Okay, so does that work? The total capacity is 4,200. So let's see if this is about right. Remember we said we wanted this to be about 3% and 126. Okay, so this math is working correctly. Now to turn this into the demand, what we're going to want is we actually need these as negative numbers. Okay, so somewhere in here we need to do a negative number. We can actually do this right here. If we multiply this by -1 instead, that'll make the T be negative. And then these demands should come out as negative as well. We are generating a T of 1 and a C of -12, but we're going to ignore those. Those aren't actually items in the game, and so the inserters will happily ignore that. Okay, so we're going to take, this is our demand, so we're going to put that on the red wire. Okay, if we look here, there's our demand. That's the set of stuff we want on the belt at this point. And when we add belts to the system, we come back here, we can update this. If we want to change the set of things that we want on the system, we update this guy or add additional things on it. And then it should actually recompute it all. So that's pretty cool. Let's get a few more of these. All right, so I'm gonna mark this, and I'm gonna call this D for demand. Okay, so we'll mark this. This is the D for the demand. All right, we are gonna compute a couple of more things here just for our own purposes, but we may have to leave that for the next episode. And so for right now, what we have done, and actually here, let's also mark what this is. We'll call this M for the memory cell. Okay, so here's our memory cell. And here's our demand. And so that is how we're going to track things, right? Green wire is going to say what's on the belt. Red wire is going to say what should be on the belt. And from that, we'll make sure that we're updating the green wire when we put things on, take things off. And then we're comparing the green wire to the red wire when we're deciding whether to put something on. And so that's it. This is going to be the brain for the sushi belt. We will, as I said, add a couple more computations, but this is the basic idea. So we've gone over the basic, I guess, mechanics of the sushi belt at this point. And so stay tuned for more, but we'll leave some additional actual putting things on and taking things off the belt as a problem for future Mystic Fish. So as always, thanks for watching. We'll see you next time. Until then, bye.